Okay, I've just been told we're live, so good evening everyone. My name is Richie and I'll be hosting this evening's DevOps Playground. But before we kick things off, just a little background on Playground. So it started back in 2015 and we've grown from about 10 people to just over 5,000 worldwide. So thanks everyone here for supporting the Playground and joining us here tonight. Our aim's always been to provide a platform to share and collaborate knowledge amongst all our members, and we do this usually just by running technical hands-on sessions with some of the most emerging and popular DevOps tools. So for those of you who haven't heard of ECS is an award-winning digital transformation consultancy. So we adopt agile and DevOps techniques to upskill teams and accelerate release cycles and drive meaningful innovation. So our skill set covers everything from cloud adoption, digital engineering to data analytics, customer experience. So yeah, before we get going, just remember to sign up to the Slack community channel so our team can offer any technical support during the Playground. And remember to have your instance login details to hand because we'll be needing those in a second. So if at any point you kind of need any a bit more time or you need to pause or anything, just hit pause and then you should be fine. And you can visit tomorrow as well once it's been pushed to our live channel. So cool. So I think that's it for the intro. So let's get cracking with the Playground. So hands-on with Jenkins, AWS, and Terraform. So for the agenda, so we'll go through what Jenkins, AWS, and Terraform are, just a brief intro. Then we'll look at as code and its benefits, so everything as code and why we need it. Then we'll have our hands-on session where we'll be deploying our application, and then we'll have a Q&A at the end. So I'll do my best to answer any questions if you just ping them on the Slack channel. So Jenkins, what is Jenkins? It's an open source continuous integration and continuous delivery platform. So what do we mean by that? And firstly, that's the practice of merging code changes from different contributors as frequently as possible to a single software project. So any modifications that are made are tested automatically, and the idea is to basically keep the code base as consistent as possible and reduce any conflicts. So changes, this day and age, they're constantly being made to an application, and our piece of work is slowly but surely going to sort of cease to reflect the actual code base. So that's why we need to constantly keep merging it back. So it's key to adopt this practice really in any just in case any sort of parallelizing events in your deployment process happen, and just kind of stop that from happening. So continuous delivery, what do we mean by that? So that's the ability to deploy your application to any environment at any time for any version. So always having a deployment ready build artifact, and that ensures that any new features can be deployed and ready for the end user as quickly as possible in a sustainable way. Because the industry is so competitive nowadays, and you just can't really afford to have any outages or downtime. So it makes releases low risk. You can incrementally change an application as opposed to just dumping a whole load of new features onto your users in one deployment. It is the most popular open source tool on the market. So yeah, it pretty much supports any combination of languages and source code repositories. There's quite a big community behind it as well. So lots of online support, lots of plugins developed to improve its capabilities as well. And it allows you to define your pipeline as code. So what we're doing tonight, effectively. So what do we mean by that? That's literally the practice of defining your deployment pipelines as code. So instead of having using a graphic user interface and configuring all the settings your pipeline needs, like what repository to pull from, how to authenticate it, how long you want to keep the builds for, what scripts to run, what branch to build, everything. Instead of going in and just typing that in, you literally just define it as a piece of code. You write it as Groovy, which is, for some of you that don't know, it's a scripting language. It's very similar to Python. Write it both statically and dynamically, so it makes it quite versatile. And when you run that code, it basically generates a pipeline in the Jenkins user interface. And that pipeline will run a script, which we're also going to be doing later, which will then deploy your application. So we'll be doing both tonight. So AWS. What is AWS? It's the world's most broadly adopted cloud platform. It's got data centers all around the world, so it makes the infrastructure on AWS so highly available. They've got 76 availability zones all across the world, and they're still building more and more. They have a load of services as well, so multiple services and always developing more. There's always a new one coming out, and you could pretty much run every aspect of the software development lifecycle using AWS services. It supports scalable infrastructure, serverless infrastructure, cloud computing, migration. It's got loads of database options, static file storage, code storage, many more that I won't go into now. Cost savings, there's quite a big emphasis on cost savings. So they allow you to visualize your usage and costs quite easily, well, actually very easily, and you only pay for what you use. So it's more attractive than sort of on-premise infrastructure where you would where it can be quite wasteful. If you pay for a load of on-premise servers and you don't end up using half of them, that's going to cost quite a lot of money. It's going to be quite wasteful. Scalable, so it's scalable and adaptable. So this makes it easy for your application to scale just depending on your demand for it. So and it's very customizable as well. They provide quite a low-cost migration service too. So it's very useful for startups and companies just getting on their feet really from an infrastructure perspective. And finally, security and reliability. So because they've got so many data centers around the world, they're really closely monitored and strictly maintained. They're very discreet and out of the way, because obviously it would be quite disastrous if there were any sort of attacks or outages. And even if there are, then they can be quite quickly remediated too, 24 hours a day. That kind of service is what they have. So yeah, from that perspective, it's good as well. So Terraform. Terraform's an open source infrastructure as code tool developed by HashiCorp. So what is infrastructure as code? It's so similar to pipeline as code, what we just discussed a second ago. It's the practice of defining your infrastructure as code. So instead of manually creating servers, databases, networks, security groups, functions, everything, you literally define it as code, run it on a machine, and it will automate everything. And like lots of tools, it does have an enterprise version, but you can do quite a lot with the open source version. It's written in HCL, which is HashiCorp configuration language, and that it's very simple, easy to use, easy to read, easy to write. I prefer it over using, other infrastructure as code tools use like JSON or YAML, for example, and it's just not very nice to write. A bit of a nightmare to read. So yeah, good from that perspective as well. So some of the key aspects of Terraform scope. So Terraform, it's got quite a large scope. It supports multiple cloud providers like AWS, Azure, Google Cloud Platform, Oracle, and many more as well. So it's quite wide-reaching. The speed of it as well, it's often quite a lot faster than other infrastructure as code tools. Licensing and support. So it's free and open source, but there is an enterprise version. And as I said just now, yeah, you can do quite a lot with the open source version. I've seen companies get everything they need just from the open source version. But for much larger companies, it would probably make sense sometimes. It just depends on your preferences and your requirements. But you'd start to see benefits like 24/7 support, cost visibility, reduction in risk, things like that. State management. So what do we mean by state? It's what infrastructure as code tools use to map the resources to your configuration and basically just keep track of the infrastructure's metadata. Usually in a JSON file, that's what Terraform state is. And in Terraform, you configure it yourself. So you store it in an S3 bucket, which S3 stands for Simple Storage Service. So one of AWS's services. You can just store all your state in there. We can put it in DynamoDB as well for state locking. Or if you had the enterprise version, Terraform Cloud, then that would manage it all for you as well. Modularization. So most of the infrastructure for any application is going to be quite complex these days. So it's going to contain a lot of resources, and using like a single script or blueprint would become quite overly complex bit difficult to maintain. So we modularize it, which is effectively just organizing the resources and making them reusable. So it means we don't have to keep declaring, we'll see later how it's all written, but it means we don't have to keep declaring resource blocks, and we can just reuse templates whenever we want to and spin up more infrastructure. And Terraform makes it quite easy, well, very easy, because it comes with native support for modules. And again, we'll go over them a little bit later. The code that we have tonight contains modules. So, and making changes. So, yeah, I mean, it's quite common to make changes in infrastructure, as well as provision them from scratch. And Terraform comes with a very in-depth plan that outlines all of your proposed changes. So as code and why we need it. So there's many benefits to as code, and it's firstly, it allows you to version your infrastructure and your pipelines. So it means that you can keep track of all the changes that anyone makes to them, and you can see a complete history of those changes. It's good against disaster recovery. So in the event of you losing all of your infrastructure or losing all of your pipelines for some reason, if the servers go down, you can just recover them straight away, just like that. And it's much faster than having someone go through and create everything manually. You give them more time to you give your engineers more time to spend on other things as opposed to manually creating things. They've written the code, and then a machine is going to run it all and spin it all up, which kind of ties in with less human error. So yeah, much less human error and manual work. It makes migration easy. So if you are ever migrating to a different cloud provider, or you are migrating to a different sort of CI/CD platform, then that makes it easy as well. You wouldn't have to do it all over again. You just have your scripts, you run them, and then that's it. And cost savings as well, which is sort of an indirect effect of your engineers having more time to do other things. So as opposed to just spending all their time doing manual stuff, they have other time to do other things as well. So that's it for the intro. Now it's time for hands-on. So tonight we're going to be setting up a pipeline as code script in Groovy. So that was the first thing that we mentioned. Then we need to configure our Jenkins instance and basically run that script, and that's going to generate a pipeline for us. And then we're going to write a pipeline script and then write some Terraform code. And then once we push to our repository, Jenkins is going to kick off a build and hopefully deploy our application. So let's get cracking. So for the initial setup, some of you may have already done this or may have already got a GitHub account, but if you don't, just make sure you sign up here, which is just a GitHub page. So create an account. And we're just going to be using one repository for this playground. So I put a link to it, but it's literally, it's this repo. So you can see this repo at the top. If you click on that link, it's just going to take you to the same one. But if you want to follow the instructions here, you can just kind of follow the instructions on this one, and then maybe, have the repository up here, because we're going to be using some of these tools up here in a second. So once you've got that, then you need your terminal and your VS Code setup. So visit this. I'm sure the support channel is sharing this at the moment, and type in your meetup username to here, and this will give you all your details. So once you type in your meetup username, click submit. Then it's going to give you a username, it's going to give you a password, it's going to give you, and then it's going to give you 3 URLs. So the first one is just going to be to a terminal. The second one is going to be, and that's basically where we're going to run all our commands and clone the repositories and everything else. The IDE is the workstation, so that's just where you're going to basically be editing files, all your VS Code. And then Jenkins is the instance you'll be using tonight. So I've already got mine up. It will give you yours if you go in there. So yeah, make sure you go into here, click on that, press submit, and then you've got all 3, and then just get all 3 of them up in a browser. These are all redundant, by the way, so I wouldn't try and use them. This is quite important as well. So you're going to need your unique animal identifier. It's how because we've got over 100 of you deploying an application. It's how we're going to distinguish between your applications. So there's going to be a prefix with your animal identifier, and then the rest of it is going to be AWS something.com, and that's going to be your website. So to make sure we don't all have the same website name, you have a unique identifier, and that's going to be the prefix of your URLs here. So you can see in this example here, my animal would be Bengal. So whatever it generates, just kind of copy that, save it somewhere on your machine, because we're going to need that later on for our variables. So I'm just going to go into my browsers. So if you see here, I've got my terminal. You print the working directory by typing pwd. You've got home, playground. If you list, you've got something called work directory. And if you go here, everything that's in the work directory is going to be in VS Code here. So you see how in this project directory, there's nothing right now. But if I cd into work dir, I'm now within this directory. So anything we're going to clone the repositories down to here, and then your workstation is going to be this. So yeah, keep your animal saved somewhere. Then once you've logged into your terminal, cd into here, and then go into your workstation. That's where it's going to be. And now we can move on to actually populating the script. So fork the repository first if you haven't done so. So open up this repository, click fork, and it's going to fork it to your own GitHub account. So this is the one that we want to use. We don't want to use this main one, the hands-on with Jenkins Terraform. Once you've forked it, it's going to be in your own account. And then just click on code here, and then the little clipboard, and that's going to copy the URL for you. Now, in the terminal up here, run these commands. So you want to git clone, and then that URL that you just copied, and then we want to cd into it. So replace forked repository with the one that I just copied from my clipboard, or the one that you just copied from your clipboard. So you want to run git clone, and then paste it in. So this is my one. Now if you run ls, you should see that it's now got our project, and if you go into here, it should all be here. So cd into it. So you've got Jenkinsfile, README, jobs, everything else. That is here. You can visualize all of it here, and you don't have to edit files here. This is why we've got this workstation for you, so you can actually edit them here. So if you go into deploy react app.groovy, we've got a script. A lot of you won't have this one, but I do. So just ignore the fact that it's populated. And just go ahead and copy it in. So everything that you see here, you want to copy that. Make sure you get every single bracket, because that will make a big difference. You go into deploy react app, just paste that in. This is what I just had in here. I just got rid of it just to show you how to paste it in. And this is it. So what's actually happening here? So we've got a few elements, as you can see. We've got pipeline job, we've got description, log rotator, concurrent builds, triggers, parameters, blah, blah, blah. We've got everything here. So we'll go through it one by one. So pipeline job, this is what everything is wrapped in. So this is just defining that you want the pipeline that we're building to be of type pipeline, which just means it's going to take a pipeline script. So you just have to define it here. So you can have multiple different types of jobs. You can have a freestyle one, a pipeline, which is what we're using, a Maven one, a multi-configuration, multi-branch. But this just specifies that we want it to be of type pipeline. And then the name just goes in the parameters here. So you can see how it's called. It's going to be called deploy React app. Then we have the description. So this is purely just for clarity. So any engineers who have logged on actually know what it is and what it does. The log rotator. So this specifies how many days you want to keep your logs for. So whenever you kick off a build, it's going to have a bunch of logs, which you can use just to see what's actually happening in the application and debug and everything else. And this just specifies I want to keep the logs for 5 days, and I only want to keep a maximum of 20 of them. So it just stops your whole workspace in Jenkins getting clogged up. Then concurrent builds. So this, we've not allowed concurrent builds. So this basically is saying we don't ever want there to be 2 builds of our application happening at the same time. So for example, if we have a couple of developers working on a project and they both push at the same time, this stops the project from building at the same time, because that might cause some errors. So whoever's got there first, that will start building, and then this disable concurrent builds will wait, and then when that one's done, the other one will build, which it's not too necessary for tonight, to be honest, because there's only going to be you guys, there's only going to be an individual on your instance, but it's just good to have there. Then we have triggers. So this is what is going to automate our pipeline. So if you can see these 5 stars here. This says I want Jenkins to check this repository every minute, and if there's ever been a change in that minute, I want to kick off a build. So it means we don't have to log in, we don't have to click anything, it's just going to automatically build for us. Then we have parameters. So we only have one parameter that our pipeline is going to take, that we want our pipeline to take, and it's going to be unique animal identifier. So as I said before, you're going to put your animal identifier in there, and then that's going to allow Jenkins to distinguish between all of your websites. Then definition. This is how we're actually defining what project we want to pull from. So the user is just going to be your own Git user, and then the Git URL is going to be the URL of your forked repository. So I forked it. This is going to be my URL. You're all going to have your own URLs, and this is it's just saying I want to clone from this repository, and then I want to build it. So now we've done that, we can commit and push it to master. So if you haven't already done so, clone down your forked repository. So what I did before when I ran those commands. So you don't actually need to provide your real name or your real email. And if you're using our workstations, then you'll need to authenticate to push. So you don't have to put your actual password in. We actually advise that you use a GitHub access token. So when the command line prompts you for your password after you've pushed, you can just paste in your access token instead of your password, and it will authenticate you. So after you run this git push here, you just have to type your username and then your password, but use your token as your password. So how do we actually generate one? If you go to GitHub, let me just duplicate that. go to the drop down here and just go to settings. Then scroll down, go to developer settings. Then go to personal access tokens. And then click generate new token. So we need to, I need to log myself in. So just call it Jenkins. Call it whatever you want actually. And make sure to give it repo permissions and user permissions. So sign in, settings, developer settings, Jenkins, and yeah, make sure to give it repo and user, and that's it. And then you can just click generate token. And then it should give you one. And if you just click this clipboard and save it somewhere on your machine, you'll be able to use that. I'm going to delete that because I don't want any of you to hack into my GitHub account. I've already got one that I set up earlier, so I'm going to be using that. But yeah, you should just be able to click that little clipboard, save it somewhere, and then we'll need to use that. So let's actually push it up. So once you've pasted it in and you're in your, if you type pwd, you should be within your React app DevOps Playground. You just run a git status. You can see that we've modified the deploy React app file. Hold on, I'm just gonna clone that again because mine okay, so this is the only one that we want to change. So once this is in there, you can run those commands. So git add, git commit, -m, populating the Jenkins job script, then git push u origin master. So okay, so git add, git commit, now we can just git push if my terminal connects, git push -u origin master. And here, you just need to type your username when prompted. And then your access token, which you've saved somewhere. And that's pushed. So once you've done that, we can actually move on to section 2. So now we need to configure Jenkins and then build that C job. So build the pipeline script that we just pushed up. So we're going to be adding our credentials globally so that Jenkins can interact with our repositories. Then we need to configure Jenkins to use Node.js so it can build and test our application. Then we need to configure Jenkins with Terraform so it can run Terraform commands. And then we need to configure Jenkins with AWS so it can actually deploy the application and knows which region to deploy it in. So let's go over to Jenkins. So first, configure the access token globally. So once you're logged in, go to Manage Jenkins, Manage Credentials. So this is whenever you click this at the top left, it's just going to take you to the home page. So if in doubt, just click Jenkins at the top. I'll need to log in actually. You guys won't need to log in, but I've just I've given myself a user so I can log in. So click Jenkins, click Manage Jenkins, scroll down to Manage Credentials. Here, click on that. Then you have Jenkins here, you have credentials, Jenkins, click on Jenkins here. Then you want to click Global Credentials, so that means that Jenkins can access them globally. So click on that. And then you should see a little Add Credentials here on the left. So go ahead and click that. Now we can configure the credentials. So leave the scope as global. You have some options, just leave it as global. Then put your username in. So I'll put mine in there. Then your password, copy the access token that we generated earlier, and then just paste it in there. It will work in the exact same way. And then put your ID as your username. Make sure that these are exactly the same, because it's the way that Jenkins is going to be able to access your credentials. So make sure username and ID are the same. Password as your access token. Description doesn't really matter. Just put them as get creds, and then go ahead and click OK. So now, whenever we build a project, it will have a drop down, and you can select these credentials if you want to use them. So these are the ones that we're going to be using. Now we need to configure Jenkins to use Node.js. So it wouldn't understand what npm stands for Node Package Manager. Jenkins wouldn't understand it has to run some commands, and it wouldn't know what that is unless we configure it that way. So before this playground, we installed plugins, so you guys didn't have to. We installed the Node.js one and the Terraform one. And once they're already installed, then you have to go in and actually create those nodes. So go to the Jenkins homepage, like we did before. Click Jenkins, and just like the credentials one, click Manage Jenkins. Then you have all these options. You have Configure System, Global Tool Configuration, Manage Credentials, which is what we just used, Security, everything else. Go to Global Tool Configuration. If you scroll to the bottom, we'll see these the plugins that we installed for you. So we've got a Node.js and we've got a Terraform. So start off with the Node.js. Just click Add Node.js here. And it will come up with all of these fields. You don't have to fill any of them in apart from the name. That's the only one you have to fill in. So fill in with Node.js. And it's important that we spell it. There's no misspellings here, because our pipeline script has Node.js just like this, and as long as they match, then Jenkins is going to know to use this one. So make sure you just have Node.js, no capitals, no nothing, just Node.js. And that's it for this one. You can leave everything else blank. You can click apply as well, but just keep on the same page. And you can scroll a little bit further down, and we have Terraform. So in the exact same way, just click add Terraform and call it Terraform. So TE. And this bit is important actually. So we need to make sure we use Linux AMD 64. Actually, it is 0923 Linux AMD 64. So click on that. 0923 Linux AMD 64. Make sure you click that one, and that's it. So Terraform, and then Terraform 0093 Linux AMD 64, and apply that. So now we've done that. We've done a Node.js installation, a Terraform installation, and you can just click save. So copy that, AWS _ default _ region, paste that in the name, and then the value needs to be EU West 2. So I'm going to copy that as well. Avoid any typos. Let's paste that right in. Make sure there's no white space either side, so just EU West 2. Click save, and that's it for the Jenkins configuration. So now we actually need to build that C job. So where are we here? Create a new item. So the Groovy code that we just pushed up earlier, we now need to create a new item and then get one of these items to actually run that script to generate our new actual deployment pipeline. So go to the Jenkins homepage and just click new item. So Jenkins here, new item, call it C job. Again, you can call it whatever you want, but just makes it more clear. And make sure it's a freestyle project. So the one that it's building is going to be a pipeline one, but we don't want this one to be a pipeline. We want this one to be a freestyle. So just click freestyle, go ahead and click OK. You can leave the description blank, doesn't really matter. Then we need to click this project is parameterized. So these are the parameters that this job's going to be taking, not the one that our new one is going to be taking. Remember how we configured it to take a unique animal identifier? That's for the new pipeline. This one just needs to take a couple of itself, which is a git URL and a git username. So if you look here, this is what makes it dynamic. We're going to give it a git URL and a git username. All of yours are going to be different. And we need to add them. So just click add parameter here. Click on string parameter. We just need to make 2 of these. So click that, that's the first one. And you can just go ahead and click it here. Oh, actually, I'll go back to the repo to make it a bit more clear. String parameter, and then the 2 variables we saw in section 1. So get user, I'll copy from here first. Leave that blank for now. You can, but we're going to build it with parameters later, and we're going to type it in there. So just leave that blank. Then go add parameter, string parameter again. So this is the last one, second and last one. And put get URL in there. So that's done for the parameters. If we scroll down, Git. So in the source code management bit, click the Git radio button and then fill in the repository URL with your forked repository, the URL of your forked repo, how we did it earlier when we went code, and then copy that clipboard. So source code management, click the Git radio button, paste in your forked repo. Just make sure that it's not this repo, otherwise we'll have some problems. So yeah, paste in your forked repo, and then credentials, we've got a little drop down, and you see how we've got the credentials that we configured earlier. So we can just click those, and now Jenkins is going to be able to interact with our GitHub and actually clone that down and then build the project, etc., etc. Leave the branch as master. We're just going to be building the master branch. And then we have one last bit to do. So we need to add a build step under the build section here. And we want it just to look on the file system. And the path is going to be jobs deploy react app.groovy. So you're telling Jenkins to go into the jobs folder and then run the deploy react app.groovy script, which is the one that we pushed up earlier. In the jobs folder, deploy react app.groovy. And whenever we build it, it's gonna run that script and generate us a pipeline. So go down a bit, add a build step, process job DSLs, and then I'm not going to type it because I've had problems before making spelling mistakes, so I'm just going to copy it straight in. So jobs / deploy react app.groovy in camel case. Whack that in there. That is done. So that's it. If you just click save or apply and save, that's it now. So now we can actually build it with parameters, which is the next part. So build the C job with parameters. Click it on the left. So where's the C job? So if you go, I'll just quickly show you Jenkins here. This is now the one that we've just created. So we created that manually ourselves. Click on it there and then click build with parameters. And now we can type our git user in and our git URL, and then that's gonna pass it through to our next application. So git user is just your own git username, and then the URL is going to be the forked repository, because everything is built through this one repo. So that's all we need. So go ahead and copy your forked one, click in there, paste it in, and then click build. Let me just double check. Okay, so yeah, go ahead and click build. Go to the Jenkins homepage. Hopefully in a second we'll see a new pipeline pop up. Not quite. Script is not approved for use. Okay, I'm going to have to approve this one. I don't think any of you will have to, but if you do, then this is how we're going to do it. So go to Jenkins, go to Manage Jenkins, and you should see here in process script approval. I'm pretty sure this is just because I've got a user, so hopefully all of you guys are going to be fine. But click in process script approval. Just click approve and go back, and then we just need to rebuild it. So exactly what we just did. Build with parameters. Hopefully this should work this time. There you go, that was quick. So that succeeded. When you have a blue ball there, it means it succeeded. With a red one, it means it hasn't. And if you go here, just click on the blue logs there, you can see that success message. Generated job, it's generated the deploy React app pipeline. There you go. So yeah, go to the Jenkins homepage and we can see that it's now built what we wrote in code. And you can just click, have a little look around in here. If you click configure, which is how we configure the project, you can see how this is now sort of a visualization of all the code that we wrote earlier. So this is, you see the description deploys a React web application to AWS. Description deploys a React web application to AWS. Then you can see how we discard old builds, log rotation, keep them for 5 days, maximum 20. You can see how that's here. All the triggers, do not allow concurrent builds, your unique animal identifier for the night. The polling of source code management, so checking it every single minute. Then you can see how it's got our credentials in there, our Git user, and the Jenkins file. Everything that we have written in here is now shown in here. So now we just need to populate the Jenkins file itself, change a variable, and then push it up, and we should see our application be deployed. So in a similar way to how we actually populated the DSL script, just go ahead and copy all of this and then paste it into the Jenkins file. So let's copy that. And make sure, just don't miss any of the brackets. The whole thing will fail even if you miss the tiniest bracket there. So copy everything, then go to the Jenkins file, which should be empty. And then paste that in. I'm just going to go back very quickly, just in case. I did put it on the README, but I don't think I mentioned it. For the actual code in here, for the jobs code, for the deploy React app Groovy, you need to make sure that this is changed. So I did put it on the README, but I don't think I said it out loud. This variable needs to not be change me. It needs to be the animal that is prefixed on your site for tonight. So mine would be coyote. And you just need to make sure you change that. And if you don't want to change it through sort of pushing, you can just go ahead and change it on here. And I'm gonna change mine actually, because I'm gonna change mine to coyote just to make it a bit more clear. So just to be clear, this shouldn't be change me. This should be your animal identifier here, unique animal identifier, coyote, and make sure. Okay, cool. So once you copy that in, let's just kind of go through it in a bit more detail, what the Jenkins file is actually doing. So pipeline, this is, so any as it says here, any declarative pipeline needs to be enclosed in a pipeline block. So it's just kind of what encapsulates everything there. The agent, this specifies where in the Jenkins environment you want your project to be run. So you can have different agents, different nodes, they're going to be running your projects. And this any here just says, they don't care which one it is, just run it in any environment, which is fine for the purposes of this, but usually you'd have a specific agent that you're using. Then we have tools. So the tools that we configured earlier, the Terraform and the Node.js, this is how we specify it. So you can see Node.js and Terraform. So this is how we configured it in the Jenkins user interface, if you remember earlier. And this is how we configure Terraform. So that's why they have to match. Because if we had spelt it wrong, if we had spelt it wrongly in the Jenkins UI, then it would throw some errors. So tools, these are the tools we'll be using: Jenkins, Node.js and Terraform. Then stage. So this is really where everything's happening. This is where the magic's happening. You've got a build stage, a test stage, and then a deploy stage. So here is build, npm install, npm run build. We'll go through what this does, what these are actually doing in a moment. Then you have your test, then you have to deploy. So this is just specifying the commands we want to run and how we're actually going to be deploying our application. I've just seen a question pop through to me. What's the difference between DSL and a Jenkins file? So DSL, I'll just answer that while you guys are pasting in or committing up to master or anything like that. DSL is this script here. So that is how you define your pipeline configuration as code. So this isn't deploying anything per se. It's just specifying, it's code that specifies how you want your pipeline to look and how you want it to be configured and what variables it's going to take and everything. So it means that we don't have to go in and click new item and build everything manually. You see how we built with parameters, clicked a button, and it just built that whole pipeline for us. So that is the actual pipeline itself, like how it's configured. And then the Jenkins file is the actual script that pipeline is going to run. So if you just to kind of visualize it, this is the pipeline that we generated with our DSL. So this is all the code visualized. And then if you scroll down, we're telling it to run the Jenkins file. So the Jenkins file is the pipeline script that this pipeline is going to run, and then that's going to deploy an application. So that's the best answer I can give. I hope that was clear enough. So stages. So we have our stages. For the deploy one, we can see how we're zipping up a file. So it passes through your unique animal identifier. So this means that all of you guys are going to have different, build zip files. Same one, otherwise it would get confused and it just wouldn't work. So it zips up your build package. It runs npm install, so that installs all of the dependencies that it needs. Then it will do an npm run build. And then that basically creates a build folder, which is kind of like a package of your application. And then if you just run that folder, that's how, on a server, that's how you'll be able to access your application. So it grabs that build folder and it zips it up, which just makes it easier to transfer over the web. And then it runs an AWS command, which is copying that zip file over to a bucket. So S3 is simple storage service. It's where we can store static files. So we copy it over to S3. And then now it's up there. It's up there for Terraform to then grab later. And then we cd, change directory into Terraform. Then we run a Terraform init and we specify the state. So remember earlier I was talking about state management. And this specifies exactly where we want our state to be held. So it's going to be in a file called youranimal.tf-state. So mine's going to be called coyote.tf-state. You're going to have different ones. And then apply will apply it. And then auto approve means you don't have to, it clicks yes to any prompts. So back to the Jenkins file, and then we have post. So this is the last bit. This is just sort of like a cleanup. If you look down here, it's just cleaning up the workspace basically, so it doesn't get clogged up. Oh, actually, and I missed out this stage. This stage isn't anything. It's got nothing to do with the application deployment. But it just runs a script that basically passes in your animal identifier, and then that script will use that and it will run a command to fetch your deployed website. So I can quickly show you display DNS. It will have your animal identifier here, which is the first argument that we passed in. Then your domain is is a load balancer tonight. So it's calling an AWS command, go and find the load balancers, and go and find the load balancer with the name playground, which is, everyone's got that prefix, playground unique identifier .dns name, and then it will just show you the DNS here. So that's how we're going to see it later. Post. Okay, that looks like everything. So once you've pasted that in, now we need to commit that up. Not just yet, actually. not just yet. We need to change one more variable in the Terraform directory. So go to Terraform, go to variables, and then this needs to be changed. So this is what is going to be matched with our unique animal identifier here. So these values need to be the same. The value in here pipeline needs to be exactly the same as it is in here. So I'm going to change that as well. Otherwise, it won't be able to deploy the application, or at least it won't be able to grab the domain if it does. So that's all we need to change. We need to change the Jenkinsfile and then the variables. That's it. And if you see, these are the only ones that we've changed, but we can see, if we want to have a look at the files, we can see that these are the ones that are actually being changed. So main TF, auto scaling module, the elastic load balancer module, and the script, it's all using this variable. It means that the fact that we're defining it here means that we don't have to go through the application and write Coyote in. It means we can just pass that value through. So if you go to modules, if you go to main, for example, you can see it here. It's being passed in. It's var is how you call the variable, var dot unique animal identifier. So that's how it's passing it through. Load balancer, it's all using it, and we'll go through the modules in a second. So if you run a git status, you should see that these are the only files that have been modified. So you've got your Jenkins file, and then you've got Terraform variables.tf. So now we need to commit that in the same way that we did earlier. Make sure we commit that up. So run a git add, git commit, and then git push. So we go git add. If you run a git status again, just quickly, you can see that's now green. And now commit. So git commit, populating the Jenkins file, and then we can just push that up. So now we just need to check the actual logs and visit the website once it's up. This source code management thing that I talked about earlier, these stars, this is what's checking the repository. So this, now we don't have to actually have to go and click anything. This is now going to look at the repository. If there's been a change, which there has, we just push the change up. If there's been a change, it's going to detect that change, and then it's going to kick off a build, and it's going to run that pipeline script. So hopefully we should see something going now. Yeah, we can see it flashing. You can see here it building. So just to be clear, we go to Jenkins, click on deploy React app, and then scroll down, click on that blue ball there, and this is going to take you to the logs. So scroll down. Now it's running. So you see how it's running npm install. That's that command here, npm install, and it's just going to go through, run all these commands and deploy. So this might take a couple minutes. So while I do that, we can actually just kind of go through in a bit more detail as to what's actually happening behind the scenes. So I explained earlier how npm install is installing the dependencies, and then npm run build is generating that package. Then test is testing our application. There's only one test, and it doesn't really do anything, but it's just to show you guys that that's what you would do if you're running tests. So apologies to the testers and the QAs out there. Then it's being zipped. So as I explained earlier, we're zipping up that build file, and then we're running that AWS S3 command to copy it up. Excuse me, to copy it up to S3, and then we're seeding into Terraform. But I can actually show you this, so you can see this being copied up. And if you go to the management console, this is the bucket, DPG November artifact bucket. click in there, and you'll have some of your builds already. So you can see how Mastiff, build, artifacts, you've all got the same ones. Well, you've all got different suffix, different prefix, and then build artifacts. So these are all your zip files. And then it goes into Terraform. So it changes directory into Terraform, and then it applies. So what it does initially is actually define the state. So if you look here, it's saying I want the state to be in myanimal.tf state. So we go to S3 again. It's a different bucket. So Amazon S3. We go to state. And we can see a load of objects. So now this is all the state. We've got .tf state, and these are all different state files, which are going to contain the same state actually. So once you've defined actually where you want your state, where you want it to be held, then you just click apply. So it's Terraform apply auto approve, and now it's going to go through this Terraform directory and actually apply all of that. So what it will do, it will run this main here, which is calling two modules. So we've got DPG November ELB, this is what I've called it. And it goes into modules, elastic load balancer. So this is our load balancer that we're deploying. And if we go into modules here, we can see it. And what it's doing, it's passing all of these values through to the module. So it's passing the security group ID, what it's going to need. Then it's passing the subnet ID. Then it's passing the unique animal identifier, which is your identifier for tonight. And what it does is it creates all of these resources. So remember before how I said we use modules. So if I ever wanted to, in this application, deploy another load balancer, I could just go in main and I could use that module. I wouldn't have to write all of this again. I've now got a template where I can use it. I don't have to keep defining or keep declaring resource blocks. So a load balancer is how you're going to access your application. So a load balancer is it's going to have some servers sitting behind it, and it just pretty self-explanatory. It balances the load on your application. So if there's a faulty server or an unhealthy server or anything, then it's going to redistribute traffic to a different server. So it just makes it much more highly available and fault tolerant. And it's going to sit, so this is the autoscaling group. This is the load balancer here. So we can see how it's called playground, which is your prefix, and then your animal identifier. Then it's got your security group. Then it's got where it's listening on, and it's got a autoscaling group. So an autoscaling group basically will scale your application up or down depending on the demand for it. So you configure that yourself. So if we go in here, autoscaling group, we can see how we've got something called launch configuration, which is saying whenever I want to spin up a new server, so if I've got an unexpected traffic to my website, a load of people are going on it, then it's going to spin up a load of new servers to make it more highly available. And we're just saying we want the instance type to be T2 small. That's just a type of server it is. We want it to have an instance profile, which is basically the permissions that it has, the AWS permissions that it has. We want it to scale up to no more than 3 servers, so maximum size 3, minimum size 1, desired capacity 1. So we want it to be floating around 1 all the time, but if needs be, then it will scale up to 3. And this actually runs a script which deploys our application. So if we see in this launch configuration here, you can see an attribute called user data. And this is passing through this data template file.init. So this is defined up here. You see this data template file init. And it runs a script. So it calls that script from here, deploy React application and then it passes in this variable. Again, the same variable we've always been seeing. It passes that through, and that's actually that's how we're going to access the application. So we can have a look at the script in here. So what it does, installs the Node.js because it's a Node.js application, and installs any updates as well. Then it sets the region, which is EUS2. Then it copies down. So it copies down that artifact that I showed you earlier in the console. It copies that down. So here, unique animal build artifacts. It copies that down so the server now has access to it. And then it unzips it. So it unzips it, and now within the server, you've actually got access to that build package. And this is the folder here that we now have access to. So we transferred it from Jenkins to our application here. And then it installs something called PM2. PM2 is basically allows our application to keep running even when it's stopped executing commands in it, or no one's actually sort of logged into it. It's going to allow us to keep anything running on that server. And then it serves that build on a local port, which is 3000. Now this wouldn't make it accessible, but we run a final command which says any traffic routed to 80, to port 80, which is HTTP, any traffic routed to there, redirect it to port 3000, and that's where the application is actually hosted. So that's pretty much an overview of what's actually happening sort of behind the scenes. We can have a look, and it did successfully build. So it ran our script, Coyote, passed it in, application successfully deployed, please visit, and then it's going to have your website here. So I don't know how long it's been, but I'm hoping that this is going to be working now. And boom, we have Random Panda. So this is just a little website I made for tonight. Panda fact gives you a little panda fact. Giant pandas are on the brink of extinction with just over 1,000 pandas left in the world. Scientists are hoping to increase the wild panda population to 5,000 by 2025. I think there's only about 10, to be honest. This is a Random Panda API. And then Random Panda background, click on that. Should get another panda background. And that is pretty much it for today's exercises. So thank you so much for joining. I hope you found it useful or enjoyable. And thanks so much to the support team as well. I'm sure they've been answering all your questions or forwarding them to me. Thanks to my housemate as well, letting me use his room. But feel free to stick around. We'll leave your instances up for you to sort of play around with as well, and the UI and everything. And if you have any questions, just post them on the Slack channel, and I think they'll be redirected to me, and I'll give it my best shot of answering them. I think I've got a question actually from Carlos. What can you tell me more about the Terraform role in this project? So this is more about, I assume this is more about what Terraform's doing here and why we need to use it. So if we had any other application, then we might have sort of spun up the infrastructure in any other way. As I said before, it could have been done manually or anything like that. But this is basically allowing the Jenkins agent to actually do that instead. So it runs those commands here. Let me just find it. So it runs here, and it automates everything. So no one's ever going to have to go in to the AWS console or anything like that and actually provision any of these resources. You've predefined that, and that's going to be versioned usually in a different project. You'd probably have it versioned somewhere else. So we've got a Terraform directory here, but in another project, you definitely would have a completely different repository. So it would be a complete infrastructure repository. Engineers will be making changes to that regularly, and then your application will be a bit more split up that way. It might not just be in one script. It might call another pipeline that builds that infrastructure. But yeah, it's just a way to sort of how we can automate it. But that is it. I've been told to wrap up. So again, thanks everyone. Thanks so much, and I hope you enjoyed it.